Good morning, everyone. I am Hanumantarao from Mobility and Industrial Solutions Department of Mitsui Chemicals India Private Limited. It's a pleasure to be here today to share insights into our advanced EPDM solutions under Mitsui EPT brand. Let's explore how our differentiated technologies are shaping the future of mobility and industrial applications. A brief introduction about myself. I have spent over 16 years in automotive and industrial business, with 14 of those years proudly associated with Mitsui Chemicals. I hold an MBA in marketing from ISB&M Pune, and beyond work, I have a keen interest in numismatics and philately. Today's presentation, we cover key areas: what is EPDM, features of Mitsui EPT, differentiated EPDM grades, and followed by summary. As per ASTM D1418 in polymer nomenclature, EPDM stands for ethylene propylene diene monomer. It's a synthetic rubber known for its excellent weather and heat resistance. Unlike natural rubber, EPDM lacks a double bond in its main chain, which contributes to its durability and stability under harsh conditions. EPDM finds extensive use in both automotive and industrial sectors. In vehicles, it is used for glass front channels, weather strips, anti-vibration parts, gomets, and hoses. Industrial applications include OA parts, insulation sponge, wire and cables, O-rings, and gaskets. Mitsui EPT is built on decades of innovation, starting with Ziegler-Natta catalyst in 1969 and advancing to metallocene catalyst in 2008. We have achieved high polymerization activity, introduction of new co-monomers, easy control of branch structures. Extremely low chlorine content enhance product longevity. In metallocene catalyst has low chlorine content. Ziegler-Natta catalyst versus metallocene catalyst. The closer to 1.0 means the sharper compositional distribution. Uniform diene distribution in metallocene catalyst helps in better processability. Differentiated EPDM grades. We offer two differentiated EPDM grades: VNB EPDM, change in diene from ENB to VNB. EPDM, change in comonomer from propylene to butene. These grades are tailored by changing diene and comonomer species, optimizing polymer structure for specific applications. VNB EPDM, high cross-linking efficiency when compared to ENB type, homogeneous cross-linking structure, designed for high heat resistance, excellent compression set, and durability. VNB EPDM demonstrates high cross-linking efficiency and superior curing properties in comparison with Ziegler-Natta ENB EPDM. VNB EPDM is designed especially for applications that require ultra-high heat resistance, good compression set, good durability, and high abrasion resistance. VNB EPDM can be vulcanized with peroxide but not with sulfur. The grade is suitable for hoses, anti-vibration rubbers, electric wires, and cables, belts, and so on. VNB EPDM outperforms conventional EPDM and even silicon in compression set and heat aging tests. VNB EPDM shows better compression set, high temperature properties, and heat resistance without secondary curing. With ultra high heat resistance, good compression set, good durability, and high abrasion resistance, applications includes hoses, anti-vibration parts, gaskets, and conveyor belts. Free volume of EPDM is larger than the conventional EPDM. EPDM is ideal for low temperature environment. It shows lower hardness, better tackiness than conventional EPDM. Mitsui metallocene EPDM is a completely new material developed for applications which require very good performance at low temperature. For example, gaskets and packing. Due to copolymerization of 1-butene C4, Mitsui metallocene EBDM shows excellent elasticity at low temperature and low hardness and high tackiness compared with conventional EPDM. Metallocene EBDM shows excellent elasticity at low temperature compared with silicone. EBDM offers superior low temperature performance, tackiness, and processability, and perfect for applications like gaskets, brake cups, and transmission belts. To summarize, Mitsui Chemicals Inc. has succeeded in commercialization of metallocene VNB EPDM and EBDM by adopting Mitsui's original metallocene catalyst technologies. Metallocene EBDM shows excellent low temperature properties under -40 degrees Celsius compared with EBDM and silicon by optimizing polymer design. VNB EPDM shows excellent aging properties over 180 degrees Celsius by optimizing polymer design. Our differentiated EPDM grades are a testament to Mitsui's commitment to innovation and quality. For further details, please reach out to me directly at hanumanta.rao@mitsuichemicals.com or visit our website at www.mitsuichemicals.com. Thank you for your attention.